My name is Hui-Nguyen, and today I will be talking about electron configuration rules. This includes Aufbau principle, Hund's rule, and Pauli exclusion principle. First, let's talk about the Aufbau principle, which is also called the building up principle. This principle states that electrons occupy orbitals in order of increasing energy. This diagram here is a representation of a method of predicting the order of filling called the Madelung rule, which is also called the N plus L rule. Orbitals are filled in order of increasing n plus L, which represents the relative energy. If two orbitals have the same value of n plus L, then they are filled in order of increasing n. The arrows here show the order of increasing energy. Now let's take orbital 3D and 4s as an example. When you add the values of n and L for both of them, 3D has a value of 5 and 4s has a value of 4. This shows that orbital 4s will come before 3D. Now let's talk about Hund's rule. This rule states that if orbitals of equal energy are being filled, the electrons are placed into each orbital in the degenerate set before they are spin paired with another electron in the same orbital. In other words, when filling out orbitals with the same energy, we have to first fill all the orbitals with one electron each, and then we can go back and add the second electron. Now let's use nitrogen as an example. Nitrogen has 3 electrons occupying the 2p orbital. According to Hund's rule, they must first occupy each of the 3 degenerate p orbitals, namely the 2px, 2py, and 2pz orbitals, with parallel spins as shown in the first configuration. The second configuration, however, is incorrect because the third electron does not occupy the empty 2pz orbital. Instead, it occupies the half-filled 2px orbital. This, therefore, is a violation of Hund's rule. Lastly, let's talk about Pauli exclusion principle. This one states, no two electron can have an identical set of 4 quantum numbers. This means an orbital can hold a maximum of 2 electrons and they have to be opposite spins. Now let's take 2 electrons in a 3s orbital as an example. Both electrons have the same principal quantum number n, the same orbital angular momentum quantum number L, the same magnetic quantum number ml. However, they have to have different spin magnetic quantum numbers ms. First example, 2 electrons are spinning in the same direction makes them having the same ms value, which violates the Pauli exclusion principle. Therefore, the second example is right, and 2 electrons have to have opposite spins.